Hi guys, Ms. McIver here, and I want to continue with some examples of stoichiometry problems that are a little more complex than just converting from moles to moles. In our previous lesson, we did these short problems where you start with moles of one substance and you're converting to moles of another substance in your chemical equation. Remember, you have to always start with a balanced chemical equation. It's also helpful to have your mole map, as we call this, out. I know it's in your packet. Maybe you want to draw it on another sheet of paper or print another copy. But what we've been doing so far is we've been starting with a known substance, and we've been given the units in moles, and we've been converting to the moles of our unknown. And that's a really short mathematical problem. It's a short train track because you just use the coefficients from your balanced chemical equation to convert from moles of one substance to another. So now we're going to move out into the region over here where we might convert to grams, or we might start with grams and convert to moles. Or like I said, we could start with moles and convert to grams. So the first example, I happen to be on page 6 in your packet. So we have this reaction of potassium chlorate, and it's going to decompose. Hopefully you recognize that decomposition, and it's going to decompose into potassium chloride and oxygen. So the first thing you need to do is balance this equation. You're going to put a 2, a 2, and then a 3. And you can do the math and check, and all your atoms are equal on each side. So now you read your problem. If you start with 25 grams of potassium chlorate, I encourage you to write it above the substance. Put the amount and the unit. How many moles of oxygen gas is produced? So this is what you're looking for. So we want the amount of oxygen in moles. Again, you can use X, I use a question mark, probably not. Math teachers wouldn't like it, but as far as your train track goes, you're going to start with what you know. Okay, you have 25 grams, and this is my known, by the way. And my oxygen is my unknown. I know some of you get that. That's the question mark. My 25 grams of potassium chlorate. It's really important that you write the unit and the substance. Yes, it's a little more work, but it keeps you organized. You want this unit to go away. So if you don't know anything else, you should at least drop the unit, grams of potassium chlorate, to the bottom. Now, what are we going to do? So here's what we're given. We start with 25 grams of potassium chlorate. And the question is, this is my known, how many moles of oxygen do I have? So my unknown is here. I drew this little dotted line down the middle. This is the information from my known over here, my unknown over here. I'm looking for moles of oxygen. So this is where I'm going. So first I need to convert from grams of potassium chlorate to moles, and then I can use the mole ratio to convert to moles of oxygen. So how many grams of potassium chlorate are in 1 mole of potassium chlorate? This is a little side problem. You would look up the mass of potassium, chlorine, and then 3 oxygens. It's going to be, and potassium, I forget, let's see, it's 39.10. You add those together and you get 122.55 grams of potassium chlorate. This should be 122.55. If it asks me for moles of potassium chlorate, I'm done, but it doesn't. I have to change substances. So I'm going to add a spot here to my train track. Now, currently the only unit I have is grams of potassium chlorate are canceling, so I only have moles of potassium chlorate. I need that unit to go away, so I drop it in the bottom. Let the train track lead you. So now where am I? Well, I have the moles of potassium chlorate, and I want to know how many moles of O2. So we're going to use the mole ratio here. I know that there's 2 moles of potassium chlorate for every 3 moles of oxygen. See that my units are going to cancel. So now you have to do the math. 25 times 3 divided by 122.55 divided by 2, and your final answer is 0.31 moles, of O2. You can put it in a box. You need to have the number, the unit, and the substance. I have 2 sig figs because I started with 2 sig figs. Okay, so for this next example, you're given the chemical equation in word form. So there's a little extra work here. We have magnesium reacts with sodium fluoride to produce sodium and magnesium fluoride. So to write this out, magnesium reacts with sodium fluoride. You check your charges, +1, -1, no subscripts needed, to produce sodium, which is just Na, and magnesium fluoride. Magnesium's a +2, fluoride's a -1, so this is going to be MgF2. Now you have to balance it. To balance it, you'd put a 2 here and a 2 here. I know it's bad form, but I'm going to put the ones here and here in red. Maybe you highlight yours or use a different color, because this is our mole ratio, and this is what's so important when I want to know the relationship between the substances. So if you react 2.645 moles of magnesium, 2.645 moles of magnesium, how many grams of sodium fluoride is needed? So I need, I put the wrong one. Shoot. How many grams of sodium fluoride? Well, here's my sodium fluoride. So I need this in grams. Again, you could put X grams. So what are we starting with? Just to show you on your mole map, if you put that back, you have 2.645 moles of, okay, so you're going to start with your moles of magnesium. So my known information goes on, let me do it this way, the left side of my map here. I'm already here in moles. I had 2.645 moles of magnesium, and what I'm looking for are the grams of sodium fluoride. So I'm going to use this map. I'm going to change from moles of magnesium to sodium fluoride, and then I'm going to convert that to grams. So we're going to use our mole ratio up front. So start with what you know. My 2.645 moles of magnesium, again, please label everything in your train track. This is what I want to go away. I'm going to use the mole ratio, I said, to change from moles of my known to my unknown. So we have 1 mole of magnesium for every 2 moles of sodium fluoride. So the good news is now I'm talking about the substance that's my unknown. I use the mole ratio to convert and talk about that substance. I want moles of sodium fluoride to go away, so I can drop that unit in the bottom. And 1 mole of sodium fluoride, you get your periodic table out, 1 sodium, 1 fluorine, are 41.99 grams. You do the math, 2.645 times 2 times 41.99 divided by 1. Your final answer, 222.1 grams of sodium fluoride. Okay, the next two examples are mass to mass stoichiometry. So if you're looking at your mole map, these are going to be starting with grams, which is mass. You're going to have to convert to moles, use your mole ratio to talk about the other substance, the unknown, and then convert to grams again. Easily we could change one of those to particles. It works the same way, but my examples are both grams. The first one here, you need to balance this chemical equation. Again, I'm going to put the 1, even though it's bad form. You've got 3 CO2s and 4 waters. What mass of oxygen will be required? So right away, the question is the mass of oxygen. So that's grams of O2. I need to know how many grams of O2 are required to react with 55.5 grams of propane. I encourage you to label it over these chemical equations so that you can keep everything organized. Start with what you know. We start our train track. As you work through, you're going to have 55.5 grams of propane. You want to drop that down here. We're going to compare it to 1 mole of propane. You go to the periodic table, 3 carbons, 8 hydrogens. You add that up, it's 44.11 grams. So now I have moles. You want to convert. We can compare moles of anything. Again, so here's where I am. I went from grams to moles, so now I use the mole ratio to start talking about the other substance. I have 1 mole of propane for every 5 moles of oxygen. If it asks me for how many moles of oxygen, I'd be done, but it doesn't. It wants it in grams, so I just convert. I know that 1 mole of oxygen is equal to its molar mass. Now this is O2, so I need 2 oxygens. That's 16 times 2, which is 32 grams of oxygen. Now pop these numbers in your calculator. 55.5 times 5 times 32 divided by 44.11. You want 3 sig figs in your final answer. 201 grams, and you need to put the substance of O2. Okay, for this last example, I went ahead and worked it out. Consider the reaction of powdered aluminum, metal, and finely ground iodine to produce aluminum iodide. So the unbalanced equation was given. I balanced that equation for you, and then I put my amounts that I was given down here. Calculate the mass of I2. That's what I'm looking for. That's my unknown, needed to react with 35 grams of aluminum. So I've worked this out for you. You start with what you know. We're going to convert aluminum to moles. We use the mole ratio to convert from aluminum, this should be aluminum, to iodine. So now we're talking about our unknown, and we're going to convert moles of iodine to grams from the periodic table. We can figure out how many grams are in every mole, and then you throw these numbers in your calculator to get your final answer. We want 3 sig figs because we started with 3 sig figs. Check Classroom for your assignment.